We are on to our last problem here. Region R is the base of a solid for each y where 0 is less than y is less than or equal to 6. The cross-section of the solid taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base in region R. Write, but do not evaluate an integral expression that gives the volume of the solid. Okay, so we have a couple different things in here that we need to think about. The first being our cross-sections are perpendicular to the y-axis, which means we are looking at cross-sections that look like this versus cross-sections that look like this. This is important because I might need to change what my equation looks like. So if I am looking at this way, I have to deal with two equations, top minus bottom. When I'm looking at this way, I'm only dealing with our 2 square root of x equation, but I need to change the direction that I'm looking at it because we're going to do things in terms of y's. So one of the things that we may need to do is change y equals 2 square root of x into an x equals equation. So in doing so, we're going to divide both sides by 2, and we are going to square both sides. So we have y squared over 4, because of 2 squared, equals x. So this is the equation that we kind of want to deal with. Y squared over 4 is going to be the distance between the curve and the y-axis. So this is going to be that slice of our base. Okay, the other thing we need to remember is that we're doing an area, and the area that we're doing is the area of a rectangle. Our rectangle is going to be a base times a height. So our base is what we just figured out. That distance between the y-axis to our function is this equation, y squared plus 4. So I have my base is y squared over 4. Our problem said whose height is 3 times the length of the base. So we're going to take that y squared over 4 and we are going to be multiplying it by 3. Okay, so I'm now going to set it and multiply this out just to make it a little bit easier for us. So I have 3 times y squared divided by 4 times 4. So I have 3 over 16, so 4 times 4 is 16, so I put all my constants together, and then I have y squared times y squared, which is going to be y to the 4th. All we need to do now is put this into our volume equation. So volume, when we have cross-sections, is the integral from our bounds of our area equation. So our bounds, in this case, because we're looking at y, we start at 0 and we go to 6. So my bounds, which they gave us in the problem, is 0 to 6. Our area equation is that 3 over 16 y to the 4th, but this time I want to write dy instead of dx because it's with respect to y. Just like the last one, this one is also going to be worth 3 points because each problem for a free response is going to be 9 points total. 2 points for the integrand, and then 1 of putting everything together.